So, again, we are going to talk about Elixir, I guess. Yeah, interesting topic. So, who I am, because who is going to talk about Elixir today? First of all, I was thinking of talking in Bulgarian, but because everybody is talking in English, I have to talk like Arnold Schwarzenegger. So, my name is Nikolay, some call me Meddle. I've been professional programmer for a long time. And I'm Elixir developer, of course, because I'm going to talk about it. And I'm doing things mainly on the back end of the world, DevOps stuff, Elixir as backend services, whatever. In the moment, blockchain stuff. I'm part of a Sofia University course that we teach Elixir actually, which I'm proud of course. And I'm a musician and poet and other things too, because people have their interests. This is me. If you need links and stuff. Now, when you do a presentation, actually the audience is more important than you. So when I do a presentation, I always think about what kind of people I'm going to present to. So I was thinking about what kind of people will be here. I talked with the organizers. So the idea is that, for me at least, I thought that you don't know about functional programming much, some of you, and you are interested to learn about it. That's why this presentation is actually very wide-hearted. You won't see code. Actually, there is one slide which is code, but it's not created by me, first of all. And second of all, it's a picture. It's not code. And there are two types of presentations that you can do on conferences for me. One is something like entertainment, like a show, which is this is about. It will be different than the other ones that you saw. And the other one is something that is more deep. For example, talking about type systems or things like that. So that won't be that. And I don't like showing code on conferences or meetups because I think that the presentation should point to interesting topics that you can basically look into after you go home. And if you want to show, for me to show you code or something like that, we have a course, right? And we use this course to show that. For example, this Wednesday that is coming, I will be showing only code and talking through the code, so I can do that too. But I won't be doing that today. Anyway, when I was young, which was some time ago, and I started in the university, I didn't have experience with programming at all. I was good in math, so I went to the university with math, and math was easy to me. And I started learning programming with C++, and it was very unnatural to me. It was this imperative style of programming. It was like changing stuff in the memory, and things are changing, but something else is changing them, and it was not natural. And in the second year, I started learning about functional programming. I saw scheme. I said, wow, this thing looks like it is natural. It is smart. It is simple. It has a lot of brackets though, but that's okay. But you had to work to get money because monies are important. So you are a musician, because if you are a musician, you can't get money if you don't do the thing that is called chalga. But that's another thing. And I'm not good at that. Anyway, so I wanted money. So around the second year, I found a job. And you had two choices then, because I wanted to do servers and stuff. It was either Java or PHP. Right? I mean, you don't have another choice if you don't want to do games, then you have to do C or something like that. But I wanted to do something that has these things, threads, whatever, to be concurrent, to be doing stuff like that. So Java. So, but it was natural to work like that because the requirements then were different than what is now. So this is around 2005, I guess. So the requirements, nobody required hundreds of thousands of users, for example. Nobody required everything to be always available. Nobody required voices over IP and things like that. Animations, maybe, yeah, Flash, but yeah. I mean, there were these Java applets though, which were animations, but they were terrible. And nobody requires things like collaboration in real time. It was simpler times. But people require stuff that work on Internet Explorer 6, for example. And that's why the requirements were simple. But this doesn't mean that there were no alternatives, because actually the alternatives are an interesting thing. Mainstream sucks, even in music, right? So alternative music is good, alternative niches are also good. So I didn't know about that at the time. I knew about Scheme then, because that's what my functional programming knowledge was then. And it was great. I saw Python and it had some structures, but that's that. But in the 80s, some people lived in the 80s. I was born in the 80s, so I can't see that I can't say that I really lived through the 80s. I was existing through the 80s. But anyway, in the 80s there were these telecom companies, and they had interesting requirements even then. For example, their software had to be concurrent. It had to support thousands of transactions because you have a lot of people that are talking at the same time, right? Telecom. They had to be fault-tolerant because if, for example, John and Anna are talking and something happens to this call, you don't want all the other calls to go down, right? So no downtime at all. And the code had to be replaceable while these programs were running because, yeah, I mean, when there is a call, you don't want all the calls to fail just for you to deploy. You can't afford that. So there was this thing called Erlang. I think that they mentioned it today, but I don't know. I don't remember. Yeah, there was this thing called Erlang, and it was a niche thing because it is interesting that a big percent of the telecom networks in Europe are actually written in this strange language, which is based on Prolog of all things. But yeah, it was a niche thing. In the 90s and early 2000s, the great imperative OOP idea was the corporate buzzword, so Java and stuff. And that's normal, because most computers were having CPUs that has one core. You don't want to be really concurrent, and you had these requirements that I described a minute ago. So requirements drive the marketplace, and that's okay. I really like free marketplaces. But times change, and that's interesting. So in the second presentation, I don't remember names because I'm stupid. So in the second presentation, we talked about Miranda, right? And it was interesting how the guy mentioned that the requirements then and the things that were required then are actually getting interesting and used now, which is what I'm saying also here. So there are times change, and this is interesting and good because nature changes, and change is actually it can be for bad, it can be for good, but usually nature changes for good, and that's how we have evolution of things. We grow. So with time, we started receiving similar requirements to the ones of the telecoms. For example, Netflix came with the streaming and everything. The buzzword, the buzz expression, reactive programming, for example, we could hear about it. So this means that we got requirements for more users at the same time, streams of data, whatever. Even I was working around 2009 on a collaborative software at the time. And we rewrote its model 4 times. Interesting thinking that the last version of the model was immutable. Everything was transformations through maps and reduces and stuff to make it at least work. And it worked. It was just very slow because it was in Java, and at the times Java was not very fast to do such things, but actually was very functional in the end to make it work, right? And computers got multi-core, more powerful, great ideas of the past that were not easy to implement before were now possible. For example, functional languages are not very good for computers if you think about it, because computers are not functional. But with time, that's why they are a bit slow. But with time, computers got faster, got more concurrent, So slowness is not a problem anymore. And things like collaboration software, as I mentioned, I worked on that for writing books, designing UI, coming with diagrams and ideas and whatever were becoming something normal. And servers had to be very concurrent. State had to be shared between thousands of people at the same time. Threads and walks and etc. got complex. I mean, I don't know if you wrote stuff with threads and walks and mutexes and stuff like that, but it is complex. But it works if you get it right. I am not saying anything. So life is complex, and turns out that physics makes sense. So if you can't have physically the same data in two places at the same time. I mean, if I want to be shared, I can't be cloned, right? I mean, I can't be cloned, but I can't be thrown to two parts. So if you could clone me, it could be good. In the real world, of course, you can't clone me. It will be terrible. But in programming, you can copy stuff. So you can be pure and be mutable, and then your life is simpler. I think that we talked about immutability today. So people started thinking about these old ideas, what we talked about today too. So functional programming was getting a bit, not a buzzword, but we have now talks here about this in Sofia. In Bulgaria, the community actually is very small, so it is something. We're getting there, right? And there are changes. Now, we for example, saw YView, the lecture, the presentation before mine. YView and Phoenix and things like that are actually very fast and compared to things like Ruby on Rails, for example, or all the Java frameworks, because of how the beam works. And the so-called actor model, of course, this thing in Erlang is not the actor model, but it's close to the actor model. I don't want to get into the details, but let's call it actor model to be simple. But that actor model started to become something like a buzzword. They call to Erlang that it has the actor model. It's not the same thing. But other languages are trying to implement the actor model. Nobody can implement the original actor model. It's a very complex thing. It's a bit, more theoretical thing. So also transforming and copying, reusing immutable data is becoming a thing in different languages, not only on the main functional languages. I don't know if you saw Rust. You can declare variables as mutable or not, depending. Of course, everything is mutable under the covers, but that's something that you can do there. And you could pass functions to functions, and functions can return functions, things that even in Java you can do that now. Of course, under the covers, it's interfaces of functions, but that's another thing. I mean, abstract classes. That's how it's implemented. And persistent data structures are becoming a thing because reusing data is good. So, what I said about the OOP languages. So, we had this thing RxJava, which became a bit famous, and C# has something like that. It's actually older. I don't remember its name. But reactive programming was a buzzword at a time. And it is a very functional concept. It is like lazy streams of data that you transform. Languages like Scala and F# were created. They were functional because functional is a bit like, you can't be really functional or really imperative. It's like you have some properties that make you more functional, and the lack of these properties make you more imperative. So some languages are very functional, like Haskell, and some languages are a bit functional, like JavaScript, for example. It has functional constructs. Actually, the history of JavaScript, if you're interested, it became as a functional language. Anyway, F# is very cool. Have you seen standard.ml, OCaml? I think that somebody mentioned ML. ML is not machine learning originally. It's about functional programming in this class of typed languages, statically typed languages. This framework AKKA in Akka, in Scala, I think they like the actor model, but they don't understand it as anybody else. And as I said, JavaScript. Even people were writing books about it. That's me. I'm a bit not very proud with this, but yeah, with Java. Anyway, here is the code. So the code. So this is, of course, I didn't write it. Another person from my team in the Elixir course wrote it, but this is what does this code do? It's in Java, first of all, I guess. It counts stuff. Anybody? Ideas? Is it easy to understand? I mean, what it does? Yes. Yes, that's interesting because people were different. So I want to promote Elixir, but not Elixir is not for everybody. Some people don't think like me or like some of us. Some people think differently. So somebody can read this thing and say, I understand it from the first time he or she sees it. But for me, it's a bit hard. This is the functional part of this thing. Basically, we stream a file. We filter lines that start with error. We take the first 40 to list. I mean, decorative style. So for some people, this style of writing code is easier to read. For me, for example. For some people, I guess this. Here is your code for today. So my message in the end is functional programming is on demand in the moment, I think. Of course, not everywhere, but compared to before, it is. If you want to be concurrent, fault-tolerant, resilient, to use buzzwords, that's the easiest way. Even imperative languages like Java, C++, C#, Rust with the type system, for example, and many things are becoming more and more functional. So learning some Erlang, Haskell, OCaml, Common Lisp, or whatever for the greater good always will make your world bigger and make you open to new ideas and to see things in different ways, so make you better programmer. Yeah. Anyway, about Elixir. Because I didn't know that we are going to talk about Elixir so much in the other talk, so I wanted to say these 4 points here that we are saying the whole day. So Elixir is functional. So in the processes that they mentioned, runs a simple sequential functional language, which is very easy to understand. You saw the code. Some of you don't understand Elixir. The code was very simple, right? It is concurrent because you have these actor-like processes that run concurrent with each other. Fault-tolerant and resilient because of the supervision system that OTP gives us. OTP is the Open Telecom platform that is basically Erlang. And it is distributed. So if a process is running here or in Japan, they communicate the same way. Of course, you have the 8 fallacies of distribution and whatever, we can talk about that a lot, but that's not what I'm saying here. It is easier to write programs that are distributed. Distribution is always hard thing. Here is something from Ricky, but anyway. So Elixir is also wonderful Internet of Things, thousands of devices sending streams of data at the same time. I worked for that also. That was my last job. So thousands of devices that were on. So water companies have these pipes and you attach devices to them, they measure pressure. All these devices around the world send data to you, which is to be analyzed, and just one deployment can handle thousands of them. It just works, simple, and in a cloud it was distributed, scalable. Elixir is good for that. Instant messaging, a lot of servers that support voice over IP and instant messaging are written in Erlang, Elixir, or something being related. For example, Discord. Blockchain for listening to blockchain changes, making something like caches. I'm working on that in the moment, for example. Even for machine learning, I hear, and there is some chance, I don't believe in it, Python to get thrown away from the machine learning space. I hope, but no. Web. We heard about WiveView. I don't need to talk about it. So Elixir is a mix of good stuff, right? And so who uses Elixir? Because I'm basically advertising the language. So big companies like Pepsi, why not? Spotify, I don't like what they are doing, but they are using it and they are a big company. Discord, Apple. Other companies like Toyota for some reason and Square Enix. And even companies that do it, which is interesting. Also me and my friends that we do the course. Other people also, some of you. I didn't know you. You are not my friends, some of you. So you use it. That's good. Why not the other ones? Yeah, people are different, and that's good. Some of you can find Elixir interesting, and if I helped you with that, I'm very happy. And now this thanks section, because it's something like a show, as I said, is my coda for today. So the pipe operator actually in Elixir comes from #, if you didn't know that, and it makes writing code very pleasant. So let's thank to F# and then OCaml. And the Rust type system is the same as OCaml's, simpler than Haskell's. Of course, we can also thank Haskell for making our lives interesting, and Matt, which is related to Haskell and Miranda. And I thank Ivan here. He is part of my team, and the only sweat with the code is his. And actually, Jose Valim is the one that showed me Elixir, and I was wow, right? I was doing Ruby then, and was on some very boring conference with Ruby, and everything was boring because Ruby, it's not very interesting. It's a toy language. For example, I worked in another company that we were dealing with transport data, and every day we had to do import of the schedules of the buses in England, in UK. And this import was written in Ruby, and was taking 8 hours a day to refresh. I came at that company, and I wrote a reactive library that was very functional in Ruby. I wrote it with it. With some optimizations, it came to 3 hours. And then another guy came after me, wrote it in Haskell. For 40 minutes, it was working. So, functional programming for you. I think about this meeting here, and that you spent some time with my presentation. Thanks.
Questions?
Hello. On some of your slide, you were saying that some node that is running in Bulgaria can communicate with the node that runs in Japan. How does it work? Is it built in the supervising system, or?
No, it's networking.
I mean, is networking built in the language somehow?
No, it uses networking, TCP, for example. So the idea is the following: you have a node, and you have another node, and there is this specific protocol that Erlang uses. That when you run a node, you have it. And basically everything that is a term in Erlang, so every value can be converted to something. There is one format, Erlang term format. I think that somebody mentioned it today. So everything can go to a binary data, so bytes. And using this protocol, then the underlying TCP, you send data. Now, this is not the important thing because everybody can do that. The important thing is the code that you write is that it is just processes sending messages, but between each other. Because sending a message to your node, to another process in your node is the same thing as code goes, as sending message to the code in another node. Now, what happens between receiving the message and sending it is different, of course, and you have a lot of problems because basically distributed systems are complex, and yeah, but we don't care about that. What I'm saying is that writing it as a code is easy. Now, supporting it is not. I would say distributed systems make sense in the same cloud when you want to scale stuff. Now, if you have a node in Japan and node in Bulgaria and they're communicating, it's not very reliable, but I wanted to have an example that you can say, wow, and ask question, I guess.
Thank you.
Thanks very much. One thing I thought you might say, and I'd ask you to comment about, in comparing Erlang and Elixir, is that Elixir is perhaps easier to get started in, and also is maybe a friendlier ecosystem. Because I've kind of scratched my head and thought, well, it can't be about syntax. You know, who cares about? It can't be just about that. But my sense is that Elixir is at a very sweet spot in its development as an ecosystem. There's one web server that everybody can concentrate on. There's one build system. There's one deployment system. Whereas with Erlang, because it didn't start off as an open source system and it's a lot older, there are different web servers and they're all, it's hard to choose and not always easy to get started and so on. So my sense is Elixir just makes a lot of those problems go away.
Yeah, but I didn't want to say something bad for Erlang, right? Because Erlang is also a good option. I don't want to arise Elixir using Erlang, right? But there are better tooling because you have mix. You have the community, which is very good community compared to this on Erlang that you said. And the syntax, yeah, the Ruby guys, I mean, they can say, wow, this looks like Ruby, maybe it is like Ruby, but it's not like Ruby, because they hit the processes and it's very different, right?
Yeah.
But now they are white too, and they tried it, and then maybe they're hooked. So,
but
yeah, drugs, right?
Yeah, okay, no, that's interesting. Yeah, thank you. I mean, the one thing it lacks is types, of course, but you know, that's another.
There is actually it has dialyzer, which talked about, but
there is one thing it lacks is types. Dialyzer and
it doesn't have static
it's
types,
not a proper type
but
system.
they're working on something in the moment. Set theory-based types, actually. I don't know if you know that.
I mean, there's nice work for Erlang on gradualizer, which I guess might get
Jose Valim is related to this work, so it's more Elixir related.
So I'll be interested to see where it goes. Yeah. But getting that either in Erlang or Elixir would be great.
It's hard because of the message passing and etc. Actually, we had a lecture.
But you need gradual typing, and that's clearly the lesson from Erlang is there have been 2 failed attempts to have a full type system. whereas the gradualizer approach, and I think there's another one. If you just say we'll only enforce types for things where you assert a type, then you can introduce it gradually, and you don't type message passing, or you do it with session
servers,
types,
for example, can be done. But
yeah,
I mean, they're getting there. By the way, there is effort in that direction.
Good.
In the moment.
I mean, if there was, it would be really that would be the killer. Thing. If you could do type-driven development in Elixir.
In the functional world, yeah. I mean, not everybody will use Elixir, even if it has static types, as you know.
Yeah, but you know, it's so nice having proper types. Yeah, pure script, but you know, pure script's still a bit niche. I'd rather, you know, and pure script doesn't have it's you know, Elixir is there. It gives you all of OTP and so on. Does pure script integrate seamlessly with OTP? Yeah. Does it? Oh, okay. So maybe that's an option. I don't know. But you know, there isn't the ecosystem. So I think, you know, if you look at, it's not just about language features, it's about ecosystem, it's about how easily you can get started, it's about a combination of things, I think. You know, why languages get take-up is complicated. And Elixir's in a strong place, but if it had types, it would be even stronger, I think.
Thank you. So you mentioned that Ruby is boring. But
to me.
Yeah, but Elixir is kind of like Ruby, and people in Akka don't understand actors.
No, Elixir is not Ruby. I mean, the syntax looks like Ruby,
yeah,
and then you get the processes that are very different than Ruby.
Yeah,
Ruby is boring because it's not very concurrent, to me.
Yeah, but just quick follow-up to the previous discussion. How about re-implementing the OTP in Haskell and forget about Ruby? Yeah.
I mean, when the OTP was implemented, actually, they needed hot code swapping because they had to be always available, right? And in statically typed language, this is a very complex task. So if they do it, cool, but let's see. Cool. I'm not I'm not specialist in Haskell. I read the book Learn Some Haskell for the Greater Good a while back, and that's it.
So a few things. One, when you have a PID, you also have a type associated with that PID, which says which messages it expects. So that's how you get type safety. It's just a type. Two, Facebook rewrote the linker for Haskell to also add code swapping, basically, hot swapping of code. So they've already kind of solved that problem to some extent. Three, Cloud Haskell is a thing, except it's not a thing. No one uses it. So basically, you can do quote-unquote Erlang in Haskell, but you basically won't because no one does it. And yes, PureScript is great. You should just use that, to be honest. But yeah, I had another question though.
Yeah,
so
that was not a question though.
Yeah. So what is the 3-step plan for someone who wants to get into, let's say, Elixir or functional programming in general? Like, what would you recommend for someone who finds themselves in a position of being honestly just lost and sort of doesn't know where to go here, right? And they might not want to just go to university to hear some old opinion or whatever about this.
Actually, going to university nowadays is not like before. You have these electable courses that young people that work in the industry are actually teaching, and if you go to these courses, and they are often taught outside work hours, so it's easy to people that work to go to them. So university is not this thing of the past that it was like before. At least here in Sofia, I mean, and I'm talking about mine. There are a lot of people that do interesting courses. Even in the moment there is a course of Vim script of all things, and a lot of people are going to it for some reason. So going to the university is not a bad thing, especially if you want to understand a bit more about math, because I think that math is important. There are people that don't think that, but I think that math is important. And university helped me a lot with abstraction, thinking about abstractions and things like that. All the different maths that I learned about helped me in some way. And I even am still reading about math theory because it's interesting to me, but this is me. So I don't think that I'm a good example for somebody because I like math. And if you like math, you would go to the university, right? Because they're good at teaching you math there, in theory, right? So I don't know, really. Everybody is different, as I said, and I think that that's good.
Right, but what are some resources that someone would use to do this, for example? Like someone wants to leave the conference and they want to jump in.
If the guy is Bulgarian, our resources of the course that I'm linked here are very good. They cover a lot of things. In Bulgarian, very simply explained, because I'm stupid and I want to explain things to other people in a way that they can understand it if they are stupid as me, right? If not, Elixir has Elixir School, which is very cool. I mean, again, simple things. I mean, you type Elixir School and you're going to find it in the net. You can learn stuff. The documentation of things like the Gen server, supervisor, registry, and whatever is so good. I haven't seen documentation of a language so good. This doesn't mean it doesn't exist. Maybe in Haskell it's better. I don't know. I see what I've seen myself. So I would say read stuff more. There are people that can learn better by watching videos in YouTube, for example. I'm not from them because I want to have my pace of getting the information, and with videos, basically who is talking is driving the pace. And reading is a good thing, I would say. And Elixir School is a good start. Otherwise, if you're Bulgarian, elixir-lang.bg. You have good materials if I don't remove them because of some people, but I won't. That's a joke, that internal joke.
Thank you.
Anyway.
Thank you.
Thank you.
We're going to have 10 minutes break.